Go. Hello and welcome back to Calculus 1. This is the second part of our lecture on the chain rule, so I call it the return of the chain rule. What we have is a technique that is the most important, most frequent differentiation technique out there. And we had quite a few examples that we did before. Now is the time to make this chain rule mix with other rules. So we have the formula, and I'll list them all here. Should I do? Let's do red. So we have the product rule formula, which was uv prime is uv plus vu prime. We had the quotient formula, which was u over v prime. We do v squared vu prime minus uv prime. And finally, we had chain rule, and we said that the derivative of f of g of x was f prime of g of x times g prime of x. So these are the three formulas that were covered the last class, and now we're going to have problems that mix these formulas in the same problem. So we start by looking at a problem, for instance, the derivative of e to the 3x cosine 6x. Now, both of those are chain rules, both functions, because you have a function 3x within e, and you have a function 6x, which is linear, within cosine. So you have two chain rules there. But the most important thing is that these two functions are multiplied, which means that you have a product rule to worry about, and then you have two chain rules inside. So this problem is a product rule with two chains inside. A chain on 3x and a chain on 6x. So those are the two chains. And the product rule is e times e to the x times sine x. Right? So those are the product rule is e times sine, and the chains are 3x and 6x because they are embedded in other functions. So when you're solving this problem, and when you see these guys, they can be in any order. You have to determine which is the main rule and which are the rules that are within, right? So because the product rule is the main rule here, because what I see here is one function times another function. So product rule is the main formula. We do the product rule formula. Copy the first times derivative of the second. Now derivative of the second is the chain rule. So times chain rule, derivative of cosine is sine, so we have negative sine, we have to keep g plugged in, and then times the derivative of g, which is 6. Plus, now copy the second, which is cosine 6x, times the derivative of the first, it's a chain rule again, so e to the 3x times 3. So we see that the entire thing is the product rule, and then you have these two chains that are there because you had to take the derivatives of the inner functions. So now this becomes negative 6 e to the 3x sine 6x plus 3 e to the 3x cosine 6x. And I said earlier that when it's possible to factor, make sure you factor, because chapter 4 is coming. So that will be 3e to the 3x. And I'm going to write the cosine term first because it's positive, and then subtract minus 2 sine 6x because that one had the negative, so I'm just going to list it second. And this would also be the answer that your homework software should have. Yes? Negative belongs to sine and still belongs to sine, right? I'm not factoring negative. I'm just rearranging them. If you have negative 3 plus 5, what's the answer? 2. If I rearrange them, it's still 2. As long as the negative belongs to 3, I can write it in any order I want. Negative belongs to sine. I can move that term to front or back. Cool? Good. So that was one of the problems. Those of you going to differential equations and physics and mechanical engineering, this derivative is extremely important, because this derivative is the derivative for displacement of the within the simple harmonic motion. You know, when something is swinging and then it eventually stops, so that will be this function. You have to have negative 3x, and the x's are t's in time and so on, but it's the same principle. Let's take a look at the next problem. The derivative of, let's go with sine squared x divided by x squared plus 1. What's the main rule? Quotient is the main rule. Great. So you're supposed to do quotient rule and then the chain rule within. Let's see. All right, so quotient rule. We know that we are supposed to square the denominator and then copy the denominator as is. And then we are taking the derivative of the numerator. So that's actually the problem that we did earlier. So we can do it on a side. We need to take the derivative of sine squared x. So I take the derivative, so this is like x squared, so it's going to be 2x, so it's 2 sine x. And then since the inner function is sine, the derivative of sine is cosine, and then using the formula from trig, you can combine this into sine 2x. So that will be sine 2x, the derivative on top, minus copy sine squared x times the derivative of the bottom, which is, right, derivative of x squared is 2x and derivative of 1 is 0. So we have the product rule formula, the quotient rule formula done. And there is really nothing that we can improve here. We can just write it as x squared plus 1 sine 2x minus 2x sine squared x divided by x squared plus 1 squared. We can't cancel x squared plus 1 because the other term doesn't have x squared plus 1, so they don't cancel. And just left there, and that's the end of the problem. So this was a quotient with a chain rule inside. How about the derivative of e to the 4x divided by 2x plus 7 raised to the 6th power? Think about that. So which one is the main rule for this one? Chain rule or quotient rule? Which rule is the main rule? Still working, still thinking? No? It's done? So what's the outer function f? X to the sixth. Good. And then the inner function g is e to the 4x divided by, so the quotient rule. So the derivative is 6x to the 5. Right? But x is this mess. And then times, now we have to do the quotient rule for the rest, which is 2x plus 7, 2x plus 7. The derivative on top is 4e to the 4x minus e to the 4x times 2 from the denominator. Now, there is stuff that can be done here to simplify this. Remember chapter 4? We go equal to 0 to solve this, right? So now we're going to do some algebra. Lock the doors. Note that in algebra you have formula a over b to the n to give you a to the n over b to the n. So each one of these gets its own 5th degree power. Also note that this 6 multiplies also the entire fraction over here. Note that 4 and 2 and e to the x's can factor out. There's a lot of things that we can combine here. So let's go. First, I am going to factor out 2 and multiply into 6 to get 12. I'm taking a 2 from here, I'm taking this 2, and this 6. When I factor the 2 from the first and multiply into 6, I get 12. So there's that. Then I have my e to the 4x to the 5th power times, and in parentheses over here, I have 2e to the 4x, maybe I can do these parentheses, times 2x plus 7, minus e to the 4x only because the 2 is already out. On the bottom over here, I have 2x plus 7 to the 5th power, and on the bottom over here I have 2x plus 7 to the 2nd power. So now I have 12. The denominator is easy. 2x plus 7 to the 7th power. Using a basic algebra that, let's say, x to the 5th times x to the square is x to the 7 because 5 plus 2 is 7. Now, on top, I get to factor this, and that's going to be e to the 4x, and then this one, it's e to the 4x to the 6th power. And what's left in parentheses is 2 times 2x plus 7 minus 1. Further, exponent of exponent multiplies. So I have, and I can put 12 on top, it's fine. So we have 12e to the 24x. And now when you multiply over here, you get 4x plus 14 minus 1 is 13. When you work that out, divided by 2x plus 7 to the 7. So now, in chapter 4, you say equal to 0, and then you have your e to the 24x equal to 0, no solution, and you have your 4x plus 13 equal to 0, where x is equal to negative 13 over 4. So the only value for x that you get is negative 13 over 4. If you never simplified, how are you going to get that from here or from here? You can't. So simplifying is important. Otherwise, you don't get to calculate this, which is going to be called critical point. You don't get to do first derivative test, second derivative test. You don't get to do any of the stuff from chapter 4 if you're not able to grind through this algebra. So please practice this algebra. Remember those algebra formulas that a, b to the n is a to the n, b to the n, a over b to the n is a on n, b and n, a to m raised to the n is a m n. Like those formulas in algebra that we use all the time to simplify expressions, especially if you're computer science, because the efficiency of your program, the software that you're writing, is based on having the formulas, mathematical formulas that have the least amount of calculations, because the processor is taking time to compute something. Sure, that's a fraction of a second, but if the computer is doing something 10,000 times and it's going to take less than half a second, it's going to take even less time if the computer has to do that 10,000 times if the formula that computer was doing had less operations, right? Because running a mathematical function 10,000 times means 10,000 times to run the calculation, but that's times the number of operations that function has. So if you have 5 calculations inside, running something 10,000 times is 50,000 calculations. If you run 10,000 times something that has 3 operations, that's 30,000 operations. So your computer science is not just faster hardware, it's also smarter programming, smarter software, which is where simplifying expressions and putting them down to the lowest terms is producing the smallest amount of calculations that need to be done. So you optimize, right, your software. All right, one more problem, and that will be it for this. This section, and then we can we'll take a short break. Now we'll see what else is there in the chapter. I'm going to get something from your homework. That combines these rules. So let's see. We're going to go into the chain rule, chapter 3. And then right after this, we're going to practice this even more. Problem 71 looks sufficiently disgusting. Yeah, why not? I was thinking of modifying another problem and making it worse, but this is... This is already interesting. What's the main rule? Come on. What's the main rule, guys? Come on. Wake up. It's too early. Too early, I guess. And then let's go home and sleep. Or you already started your spring break, so it's like, yeah, I'm not. Why am I here? So we rewrite this as x to the 4 plus cosine 2x to the 1/5. So we have x to the 1/5 as the outer, then g is x to the 4 plus cosine 2x, and then h if you want to go with the cosine 2x, but you can always use the shortcut formula with a, so you don't have to count 2x as a separate function. So the derivative is 1/5, and now you have the entire parenthesis to the negative 4/5 because you subtracted 1, times the derivative of the inside, which is 4x cubed minus 2 sine 2x, and finally times 2. Oh no, sorry, no times 2, I already did that, it's right here, sorry. So now just clean this up a little bit, not much you can do. 4x cubed minus 2 sine 2x divided by 5 times 5th root of x to the 4 plus cosine 2x to the 4th power. When you set this equal to 0, the entire denominator disappears, so you just have to worry about this. And that is actually something that you can solve using algebra. You have to use graphical methods or other approximations because you have a combination of a polynomial and sign. But we'll deal with that when we get there. Let's take a break. When we come back, application of chain rule, which is known as implicit differentiation. Bye.